Okay, number 5, a billion-dollar question. Show that a group where every element has order 2 must be abelian. So let's break this question down and give ourselves some notation first. So let's call our group G under the operation star. And we know that every element in this group has order 2. So let's remember what it means to be the order of an element of a group. So the order of an element, little g, in our group big G, is the smallest n such that g to the n is equal to e, which is the identity element. So in our case, every element has order 2. So we can write this down as, for all little g in our group, little g star little g is equal to e, the identity. And we want to show that this group must be abelian. So let's recall the definition. A group is abelian if its operation is commutative. So if we want to show that it's abelian, what we really want to show is that if you take any pair of elements from our group, A and B, we want to show that A star B is equal to B star A. And we can do this by starting off with A star B, doing some manipulation using the fact that we know that the order is 2 for every single element, and end up with B star A. I encourage you guys to pause here and try to figure out what these middle steps will be on your own. Okay, so we know A star B is of course equal to itself, but we need to do some manipulation to this. One thing we can do is apply the star operation with the identity element, since we know that doesn't change what we're dealing with here. So we can do A star B star the identity, or the identity star A star B. But since we know that the order of every single element in this group is 2, we have a really nice way of writing down the identity in terms of an element star itself. So I'm going to star our starting quantity on either side by the identity, but I'm going to represent the identity as B star B on the left, star A on the right. And remember, this is okay because we're really just starring with the identity element. By writing it out this way, let's just copy down what this is. We notice that we have a representation of one element of our group, B star A, star itself, B star A again. And using the fact that the order of every single element in the group is 2 again, we see that this entire quantity itself is also equal to the identity, which means we have B star the identity star A, which of course is just B star A, which is what we wanted to show, and we're done.